Hi guys, I'm Sinead Galinto, Owner Technical Director here at Geochemical Oil and Gas. Today I wanted to answer one of the questions that we received on our LinkedIn page. So today's topic is going to be rheology and more specifically cross-linked fluid systems. Now we don't see a lot of cross-linked fluid systems here in the US, but in high temperature areas and internationally they're still being used. And so I'm excited to help some of our international colleagues with this question. So the question reads, during some high temperature lab tests using a Chandler 5550 equipment, which is a piece of equipment we own, it's been noticed that during shear change, the viscosity in the plot can decrease significantly, and the M' results show negative numbers. What do you think about that? Bob-Klein theory or another answer for this issue? So I'll answer this based on my experience running these types of tests here at Geochemical as well as past rules. There's a couple things that we have to keep in mind with rheology measurements. One, it's going to be the actual fluid itself. There are a lot of different cross-linkers, a lot of possible combinations with other chemistries that will give you what you consider an optimized fluid system. Everyone's got a different formulation, and that's going to behave differently on your test. So keep that in mind. The other one is going to be the actual temperature of the test. The higher the temperature, the more difficult it's going to be to achieve that perfect stable fluid. And that's because we're asking these chemistries to work in much harsher environments. So the harsher the environment, the more difficult it's going to be to achieve performance of something that we would be testing at lower temperatures. And then third, it's going to be the actual test equipment. And for your question, Bob-Klein, we're going to see it on any piece of equipment that has a Bob configuration. And part of that is due to the way the equipment is designed. Most of rheological measurements are taken in a very small space. And now you're trying to put a very thick fluid, which is what a cross-linked fluid is designed to be, into a very small space. And we're talking millimeters thick. And we're trying to put a very thick fluid in it. The likelihood that it's going to want to move around and shift and not go back into place is pretty high. And so that's also going to affect what you see when you're running these tests. Now, when you're talking about Bob-Klein, what you would see on a test is if your viscosity is 1,000 centipoise, you have a nice straight line, and then all of a sudden you see that line just drops off to say 600, and then it stays low, and then it slowly creeps back up to 1,000, and then continues to stay at 1,000. Now, that could be due to a couple of different things. In my experience where I've seen it, and that's going to affect your NMK prime readings, is always at the first shear rate sweep. And here what we're doing is we're going from a set speed, and a shear rate sweep, we're changing that speed. And so when we're changing that speed, we're affecting how that fluid is moving inside the equipment. So two things are going to affect that. One is at the beginning of your test, the fluid is heating up to your temperature. Chemistry is still adjusting, the fluid's still adjusting, and so you're likely not going to get an ideal N value. For the most part, I almost always ignore that first N and K value. By the time we get to the second one, the fluid's already at temperature, it's at time to adjust. We should see the N and K values smooth out. But because a shear rate sweep is changing the speed, and we're dealing with a very thick fluid, again, we're changing how fast that fluid is moving, going from slow to really fast. The likelihood here is the fluid is trying to shift and the speed is causing it to move faster and potentially fall out of alignment. And that would result in you seeing that change of viscosity that drops down and then comes back up. So based on my experience, I always attribute those types of fluctuations to the Bob-Klein theory. Hopefully that answers your question, and if you have any other questions, feel free to send them in to our LinkedIn page, or you can email us at info@geochemical.com. Thank you.